Hello everyone, let us continue with our lesson. Last time we just started the nucleophilic addition of carbonyl compound. Before we go further, I would like to do some revision with you, okay? So, do you still remember what we have learned last time? Okay, let's take a look. So last time I'm saying we have a reaction, nucleophilic addition, okay, with HCN, okay. I'm now talking about the reactions of carbonyl compound. So for example, if we have a reaction like that, then what will be happening at the end will be this H will go here, okay, and the double bond of CO becomes single bond, and then the CN here will go here, okay. Then last time we talked about the mechanism. Do you remember how to draw the mechanism? For the mechanism, the reaction has two parts, two steps, okay? So the first step will be like that. Since this is a polar bond, so it bears a partial negative, and this bears partial positive. So what will be happening is the Cn minus, because this HCN in water, it acts as a weak acid, so it will give out these two ions. So basically these three, 1, 2, 3, are present in the reaction mixture, okay? So what's happening is this lone pair will form a bond with this C, and one of the bond will be broken. So it becomes okay, or you can simply show one lone pair is also okay. Less confusing because you need one lone pair to continue. Okay, so this will be your intermediate. Okay, and then for step 2, the intermediate is going to capture a hydrogen ion from HCN. So here, form a bond, and this bond is broken. So the product will be what I mentioned. We become like that, okay? Hydroxynitrile, okay? So this will be the product. So remember to remember this mechanism. And there are two reactions we learned as well besides the nucleophilic addition of HCN. First, we know that the CN group in acidic medium, it can be hydrolyzed into COOH. Do you remember? Plus NH4 plus. So basically you have to remember this, okay? This is hydrolysis of a nitrile group in acidic medium. Okay? And the second one will be if you reduce the CN with sodium in ethanol, then the CN group will become amine. CH2 and H2. Remember, right? We need Na in ethanol, or you can use LiAlH4 in dry ether. Remember, if you use LiAlH4, you do not need to heat because it's already a very, very reactive reducing agent. So this is what I mentioned last time. Do you remember? Okay, then let's just continue to go back to to the handout. Yeah, okay. Now last time I asked you to try this question. Let's take a look together. Try. Have you tried? Anyway, I will go through this question with you now. Okay. Ethanediol is used, okay, so can be oxidized and reduced. What's the structural formula formed when it is reduced? So the aldehyde, when it is reduced, it goes back to its primary alcohol. So the structure will be CH2OH, CH2OH. Any question with both sides bearing the primary alcohol? Which reagent? Of course, you know now. NaBH4 in sodium hydroxide solution. Or you can use lithium aluminum hydride. It's also okay. In dry either. I mean lithium tetrahydroaluminate. Okay? Oh, now this seems to be a very complicated one, but let's go to the question directly. The production in step 3. So look at step 3. Involves the hydrogenation and a mixture will be formed. What reagent is so far used in laboratory to reduce a CO group? Okay. Now, what's the question trying to do is if we use hydrogenation, if we add H2, use hydrogenation, you will reduce both the double bond and reduce the CO group at the same time, okay, CO group at the same time. But if you just want to reduce the CO group, okay, without reducing it, then you will have to use a milder, a weaker reducing agent. So the answer is still the same, NaBH4, and the solvent is NaOH aqueous. That's it. Do you understand? Okay, I still have a few more minutes to go. Let me give you a summary or an introduction on what we're going to learn. Now, in the coming part, we're going to learn 3 reagents, okay, to test for the carbonyl compound. The first one, very important, we're going to talk about this first, is called 2,4-dinitrophenylhydrazine. Okay, 2,4-dinitrophenylhydrazine, and you can also call it the 2,4-DNP. But if the question asks you to name it, then this one, okay, 2,4-dinitrophenylhydrazine is used to test both the aldehyde and ketone. Of course, I will explain the reactions involved later, but I just want to let you know that what it is. So if the compound that you're testing contains either one of them or both of them, then you will get the orange precipitate. Okay, and orange precipitate has a name. It's called 2,4-dinitrophenylhydrazone. So hydrazine. What a beautiful name. Remember, 2,4-dinitrophenylhydrazine is used to detect the presence of either aldehyde or ketone, both of them. But if you want to distinguish between aldehyde and ketone, you have 2 other reagents you need to know. First one is Tonan's reagent. I will tell you what it is later. It's just used to test for aldehyde and no reaction for ketone. Okay? If the result is positive, then you will get a silver mirror on the test tube wall. Okay? I will explain this later. That means on the test tube, on the wall of the test tube, you will see a silver mirror. So it's like a mirror. You can even see your own reflection from the wall of the test tube. I will show you some video later, and I will demonstrate this experiment to you after we come back. What a freak. Okay. Oh, the last one is called, I forgot how to spell it. Finnan's reagent. Let me look at the handle first. Yeah. FeHling. Finnan's solution is also used to test for aldehyde, but not ketone. Okay. So if there is a positive result, then you will see a red precipitate. Okay, I will explain the reactions a little bit for this one later. And the fourth one, we know that is we can use acidified dichromates with some heating. For aldehyde, you learned it already. It can be oxidized to carboxylic acid. So at the same time, the dichromate will be reduced to chromium-free ion. So you can see the color will change from orange to green. But for ketone, there is no reaction because ketone is resistant to oxidation. Okay? Now, okay, that's the end of this video. And then for the next video, I will start talking about the reactions involved from 2,4-dinitrophenylhydrazine. You have to know why each of them works for distinguishing both aldehyde and ketone. Okay, bye.